Have you ever watched the cool kids type those long command lines and wish you knew what they were doing? In this video, we will take a look at some tricks and tips for chaining multiple commands onto one line. Please help me out by hitting the subscribe button so I can continue to rock you like a hurricane. The Linux command line uses a lot of punctuation marks to mean different things on the command line. We're primarily going to focus on what's called chaining operators, or basically symbols that connect separate commands. The first symbol I'm going to cover is the semicolon. The semicolon basically tells the command line interpreter to execute everything before the semicolon, and then when it's finished, execute everything until the next chaining operator or the end of the command line. So basically the commands are run sequentially, each starting after the previous command completes. So let's take a look at an example. Here I'm going to do ls-ld /temp/test, and then I'm going to use a semicolon, and then make dir -v /temp/test, and then semicolon ls-ld of /temp/test. So basically here I'm listing for a directory that does not exist, and then after that runs, right, that's what the semicolon is, and it's going to create that folder, and then after that runs, after that second semicolon, it is going to do a listing again for the folder that I just created. So you can see from the output that the first line is the error from the first ls of the non-existing file. Then the second line of output is the make dir command informing you what folder was just created. And then the third line is the result of the successful listing of the folder now that we've created it. So an example usage in the forensics world is if we want to do an image of a device, and then after that, we want to run the MD5 command. Well, on a normal basis, what you would do is you would run your command for your imaging and then wait for it's done. And then when that's done, then you can do the MD5. However, you might have to wait a couple hours until the imaging is finished. So if the imaging finishes at 2 in the morning, you're not likely going to sit there at 2 in the morning to type in the next command, right? So if we use the semicolons, this would basically maximize time. And at 2 a.m. when the first command is finished, then it will run the second command and then the third command and so forth. So let's take a look at this example. We're going to do sudo dd if equals /dev /mmcblk0p2 of equals p2.dd status equals progress semicolon sudo md5 sum p2.dd greater than p2 underscore md5.text semicolon cat p2 md5.text. So this command will run the dd on the specified media device, and then when the imaging is complete, it will compute the md5 hash of the output, the p2.dd file, and then redirect that result into a file. And lastly, it is going to cat the output of that md5 text file out to the screen. So this is especially useful when the images are very large, right? And I want the machines to be working all night while I'm home sleeping. And using the semicolon chaining operators will allow the commands to run one after the other without actually having a human sit there and wait for one to end before typing in the other. So if you notice in this particular chain here, 3 commands, the first command is creating that DD file, and then the second command relies on the existence of that DD file before it can run the MD5 sum, right? So it has to wait till the first command is finished. And then similarly, the third command relies on the output of the second command to finish, right? Writing that p2 md5.txt file before it can cat the contents out. So once again, the semicolon is a separator that will allow you to run commands sequentially one after the other, especially when the commands rely on the previous portion for input. The next symbol to cover is the ampersand. The ampersand will tell the command line interpreter to run the command in the background. So what this does is to give the command line prompt back to the user to perform other tasks. This was very useful back in the old days when there were not multiple terminals and displays that one can use on a machine. but it still has its usages today if you are SSHing into a remote machine and then need to terminal to run multiple commands at the same time. So an example usage for a forensics world is if I want to get the MD5 of multiple different images, I don't have to wait one after the other. I can get them all running in parallel. So I can do sudo md5 sum /dev/mmcblk0 and then redirect the output into block0 underscore md5.txt. And then I'm going to add the ampersand at the end of that. Once I hit return, I get my prompt back, but the command is not done running. So I can run another command. I can do sudo md5 sum /dev/sda1 and redirect that into sda1 underscore md5.txt. And then again, I'm going to put the ampersand at the end of that and hit return. And so again, you see that I get returned back to my command prompt. And here I can type jobs to see what is in the background. And in this instance, looks like some of these are already finished. But once again, the whole idea is that you can run multiple things in the background and still have your command prompt so you can run other things. The next symbol to cover is the pipe. A pipe will take the output from whatever is on the left of the symbol and then feed it as input to the program on the right-hand side of the symbol. So basically, piping allows the chained execution of commands, each performing an operation on the data set and then passing the output onwards to the next program. So a simple example is if we do ls-l of /etc, right? We know that this is going to be a lot of output, but then what we're going to do is pipe that into the less command. So now this is going to pass the output of the ls command into the less command, which will take long pages and allow one to read them one at a time. An example usage in the forensics world is if we do sudo dc3dd if equals /dev/mmcblk0, count equals 10,000. I'm just putting a smaller number on here so that it speeds it up for the sake of this demo. And now I'm going to pipe that output, right? Instead of having the output go into a file, I'm going to pipe that output into a second program called EWF acquire stream. And I'm going to use the -L for log mmcblk0.txt -S1 MIB -T mmcblk0. And then once that's done, I'm going to do an ls-lth to take a look at the output. So what this is doing is that we're using the dc3dd command to read a media device and then feed the output DD stream into the second program called EWF acquire stream, which is going to create a E01 image set. And when we take a look at the output, we can see that it produced a bunch of E01, E02, E03, etc. files. And in the incident response world, the pipe is really useful when you're looking at logs, because there are a lot of utilities in Linux like awk and sed and grep and so forth that can filter data through different log files. So as you use one program for a specific purpose, you can pipe the output to a second program, which will perform a different set of filtering, and then pipe that into a third program, which will do yet another set of filtering until you get the analysis results that you want. So definitely very, very useful. The AND operator, represented by the double ampersand, separates a command line into two segments, before and after the double ampersand. The shell will execute the second command only if the first command succeeds. If the first command fails, then the second command will not be executed. So a simple example is if we do ls-l of /etc/password, and then ampersand md5 sum of /etc/password. If we execute this, we see that since ls sees the password file, which means it successfully ran, the shell would then run the second portion, which is the md5 command. So if we try another example of ls-l of /etc/blah, ampersand md5 sum of etc blah, In this particular example, since ls does not see the blah file, the first portion fails, which means the shell will not execute the second portion. So from the output here, we know that the second command, which is the md5 sum command, did not run, because if you feed md5 sum a file that does not exist, it's going to give you an error. So we know that the AND connector only executed the first portion and not the second portion. The OR operator, represented by the double pipe symbols, separates a command line into two segments, before and after the OR, or the double pipe. The shell will execute the command only if the first command fails. And if the first command succeeds, then the second command will not be executed. So let's take a look at an example. Let's take a look at the current folder. We'll just do an ls, see what files we have. So let's go ahead and do an ls-l on mmcblk0.e01.text. And then we're going to do a OR, so two pipes, into ewf verify -l mmcblk0.e01.text mmcblk0.e01. So what this does is that it's going to do an ls of this file mmcblk0.e01.text, which does not exist, right? So because the first portion of the connector fails, then it is going to execute the second portion, which is the ewf verify command. So what the ewf verify command is going to do is basically read the e01 file and then write the logs of the hash into the mmcblk0.e01.text file. So it's going to create that text file. So now if we do ls, we can see that the text file was in fact created. So this did the right thing. Of first part fails, then it will run the second part. So let's do this again. This time we're going to do ls-l of blk0md5.text. And we're going to OR that with the ewf verify -l blk0_md5.text/dev/mmcblk0. So in this second example, see the ls command does see the text file. The shell will not run the second portion, which is the ewf verify command. So a user can combine the and OR operators to create if-then-else statements or other more complex compound statements. So let's do an ls again to see what we have. Now we're going to do an example of ls p2.dd && echo double quotes file found end double quote, and then or echo double quote you fail end double quote. So a common question when these operators are combined is, what is the order of precedence, right? Like in basic math, when you have the addition, subtraction, division, multiplication, there is a certain order of precedence on which things to execute first. In the bash shell, the and OR operators have the same precedence. So then the leftmost operation is carried out first, just like the reading of the command line. It goes from the left to the right. So essentially, this is a if-then-else statement. If the first command is true, then it's going to execute the second statement. Otherwise, if it's false, then it is going to execute the third statement. So essentially, the command line looks like it's going to be ordered this way. Right? It's going to execute the ls command first, and then it is going to AND it with the echo file found, and then the OR operator afterwards. So since the p2.dd file does exist, right, it is going to execute the second portion of the AND statement, which is echo the file found statement to the screen. And because that was successful, it will not execute anything after the OR statement. If we change the command to do ls on a file that does not exist, then the ls will fail, and then the AND will not execute, right? The echo file will not execute, but then the OR statement will execute because the first portion failed. And so it will echo you fail to the screen. And you can also be specific with the precedence by using the brackets. So if we have a command like ls p1.dd and echo file not found, or echo you fail, and echo bonus round, the order of precedence of this, again, because and OR are the same, it will go from left to the right. So it is going to execute the lsp1.dd, which does not exist. So the AND will fail, right? So it is not going to echo the file found, which means that it will execute the thing after the OR statement. So it will echo the you fail. And then lastly, because again, it is the AND statement and the first part succeeded with the echo you fail, it is also going to echo bonus round. And if we use brackets and put those around, let's say, the middle two commands, this drastically changes everything. If we had lsp1.dd, it will execute and come back false. So then it will not execute anything within the brackets because it's an AND statement. Then lastly, it will also not execute the bonus round because the first part failed. So once again, the brackets will determine what gets evaluated first. Otherwise, it is going to be left to right order of evaluation. The backslash symbol, when used at the end of a command line, is the continuation character. It basically allows the command to span multiple lines without being executed, even though you hit the return key. And basically, it's just to make things look pretty on the command line. So let's take a look at an example. So if we type out sudo dc3dd if equals /dev/sda hash equals md5 log equals admin/prelog.txt, pipe that to ewf acquire stream -l mmcblk0.txt -S 1 mib -t mmcblk0 -C 201103-0105 -D double quote SanDisk 1 GB SSD end double quote -E mmc block 0 -lowercase e quote Sam Singer end quote. Right, this is one long line that we would type for imaging a device. And this is perfectly fine if you're the only person that's going to look at it. However, there are times when you actually want the output on the screen to actually look pretty and easier to read. So this is where the line continuation comes in. So I'm going to redo the exact same command, but I'm going to break it up in a way that makes it a little bit easier to read. So we're going to do sudo dc3dd if equals /dev/sda hash equals md5 log equals admin/prelog.txt. And now I'm going to add a backslash and then hit return. Right? So when I hit return, because I have the backslash, the shell will not execute the command. Notice that we have a greater than symbol at the beginning of the line. Right? This basically is a clue that tells you, hey, we're basically doing a continuation. So I'm going to go ahead and continue typing my command. So now I'm going to do pipe ewf acquire stream -l mmc block 0.txt -S 1 mb -t mmc blk0. Once again, here I am going to use the backslash and then enter. And once again, you see the greater than symbol at the beginning of the line to tell us that, hey, you're still typing your command. I'm not executing anything yet. So I'm going to continue with a -C 2011-03-0105 -D double quote SanDisk 1 GB SSD end double quote. Once again, I'm going to do backslash enter. And once again, we're going to get the greater than symbol. Then I'm going to do a couple of spaces -E mmc blk0 -E double quote Sam Singer end double quote. Now that I'm done with the complete line, I can hit return and it will run. But before I do that, I just want to show you the difference between having the line continuation and not having the line continuation. It does make it a lot easier to read, right? You can group different commands together and you can indent their options and whatnot. Clearly a personal preference if you want to use this chaining operator. So you might actually have gotten into this particular mode of line continuation without even knowing it, right? You might have had in the past certain instances where you actually see this greater than symbol at the beginning of the line and you don't know what's going on. Well, more than likely what happened is that you have a mismatch quote. So you either have a single quote or double quote that didn't have the ending single quote or double quote. And then the command line doesn't know how to conclude itself, so that's why you get this greater than symbol. And so a lot of times you can either hit single quote or double quote to have it execute, or hit Control-C because you kind of made a mistake somewhere. So that's how you would get out of the line continuation mode if you got into it by mistake. For more videos on Linux tips and tricks, make sure you watch these videos here. Or if you want to roll the dice on what to watch next, click on here. Thanks for your time and happy hunting.